We will do colligative properties again, but colligative properties, as you know, it depends on the number of solute particles in solution, and it does not depend on the nature of the particles. As we saw in the previous video about vapor pressure, there are 4 colligative properties: vapor pressure depression, boiling point elevation, freezing point lowering or depression, and osmotic pressure. This video will deal on boiling point elevation. So let's, before going into boiling point elevation, let's just understand what boiling point is. Boiling point is the temperature at which vapor pressure equals the atmosphere. Just now we saw in the previous video that if you have a solute present, the vapor pressure is lower, and hence a solution has to be heated more in order that it equals the atmospheric pressure, and therefore boiling point is always elevated, and elevation in boiling point delta Tb is equal to IKBM. So in the boiling point elevation equation, you saw something called as I. That I is called as the vanthoff factor, and that's equal to the actual number of particles in solution divided by the number of formula units initially dissolved in solution. And a table shows the value of I. For example, if it was sucrose, it doesn't dissociate, therefore I is equal to 1. But in case if it was calcium chloride, it will have 1 calcium ion and 2 Cl ion, therefore it will be equal to 3. Or in other words, I can say I is the vanthoff factor equal to the number of ions in solution. We will do one question on the boiling point elevation, and as you know, boiling point elevation is delta Tb IKBM. So calculate the boiling point of a solution made from 9.65 grams of barium nitrate dissolved in 300 grams of water. The boiling point constant for water is given, and the boiling point of pure water is also given. So in order to calculate the boiling point elevation delta Tb, I need to get the molality, and here the mass of the solute is given. From the mass of the solute, calculate the moles, and from the moles, calculate the molality. So now we will use that formula and then calculate the boiling point elevation. I, the vanthoff factor for barium nitrate, will be equal to 3 because it will produce 3 ions, barium and 2 nitrate. And substituting all the values in the equation, we get the boiling point elevation as 0.189. Therefore, the boiling point of the solution will be 100 plus this, it is 100.189. We will do one more question on colligative properties on the boiling point elevation. A solution is prepared by dissolving 465 grams of sulfur. Note the formula for sulfur is S8 in 1500 grams of CCl4. You are supposed to calculate the boiling point of the solution. Kb is given, boiling point of pure CCl4 is given, and the molar mass of S8 is also given. So in order to calculate the boiling point elevation, I need to first get the molality with the formula moles of solute divided by kilogram of solvent. So I need to get the moles of sulfur 8. I have the mass of sulfur, so mass divided by the molar mass gives me the moles of sulfur. Once I get the moles of sulfur, I calculate the molality. After I calculate the molality, use the delta Tb equation and get the delta Tb value. And I get delta Tb at 6.11 degrees Celsius. And now add it up to the boiling point of the original solvent CCl4. I get the increased boiling point of the solution because of the addition of sulfur. Calculate the volume of water to be added to 750 milliliter of ethanol. That increases the boiling point of ethanol by 15 degrees Celsius. The Kb of ethanol is given, and the density of water and ethanol are also given. So this is a different kind of a question where the boiling point elevation is given, and they are asking how much of the solute is to be added to increase the boiling point of the solvent. And note that ethanol is the solvent here and water is the solute. So let's just divide the whole question into steps. The step 1 is to calculate the molality of water using delta TB equals I kBm. So delta TB is given as 50 and calculate the molality of water, and I get that equal to 12.3 m. Now step 2 will be to calculate the moles of water using our usual formula, molality equals moles of water divided by kilogram of ethanol, and mass of ethanol can be calculated since the density and the volume is given. And once I get the mass of water, mass of ethanol, get the moles of water, and I get moles of water as 7.27 moles. So we just did step 1 and step 2. We'll go to the step 3 to calculate the mass of water. Mass of water is equal to mole times molar mass, and we've just calculated the moles and we know the molar mass. So calculate the mass of water. Once I calculate the mass of water using the density, I can get the volume of water, and the volume of water comes equal to 131 milliliter. Or in other words, this is the amount of water that should be added to the ethanol to cause a boiling point elevation.